pay you the head bowed salutation for your encouragement and love and affection showered for my previous videos. My dear students, I am requesting you humbly, please subscribe, like, comment, and share my video for others also. Thanking you. Cayley-Hamilton Theorem, example number 3. My dear students, if A equal to the matrix 2 minus 1, 3, 2, and then find the characteristic equation, number 1, number 2, find the characteristic roots of this characteristic equation, roots we have to find out, and verify the Cayley-Hamilton theorem, and hence find the A inverse. Okay, and this is given in question paper. And solution, by the data A is given by examiner 2 minus 1, 3, 2. This is a square matrix. Now, my dear students, number 1, the characteristic equation equal to the determinant of A minus lambda I equal to 0. My dear students, and if you use this formula, determinant minus A minus lambda I, it will take more time. So that I can use the shortcut method, or the same characteristic equation can be found by lambda square minus lambda summation of diagonal elements D. Summation of D means summation of diagonal elements plus determinant of A equal to 0. And if you found them, and you can get a characteristic equation. Okay. Now, lambda square minus lambda, the summation of diagonals. Look here, summation of diagonals. 2 plus 2. Look here, 2 plus 2 plus determinant. 2 into 2. 2 into 2 it is not 4. Sorry. 2 into 2. 2 into, look here, 2 into 2 minus of minus means plus 3 into 1. Then simplification, lambda square minus 4 lambda. This is 2 into 2, 4. 4 into 3, 7 it is. And this is a characteristic equation. Call it as equation number 1. Okay. One answer you got. Then lambda square minus 4 lambda plus 7 equal to 0. And you have to find out characteristic roots. Means find the value of the lambda. And this is quadratic equation. A lambda square plus B lambda plus C equal to 0. And characteristic equation in high school you have studied x equal to minus B plus or minus square root of B square minus 4AC upon 2A. Same formula. Instead of x here, you are having lambda. Lambda equal to minus B plus or minus root of B square minus 4AC upon 2A. Now, by using this formula, calculation becomes what? The length, so that you can do this by shortcut method. My dear students, throughout this problem, I am using the FX 991 ES plus calculator. Okay, and on the calculator, and press the mode button, and then number 5 button, that is equation. All equations are opened there, and this is a quadratic equation, and press the 3, and such a dialog box is opened there. Look here, such a dialog box is opened here. Look here, cursor is here, dancing. And here, you have to enter the value. Look here. The lambda square, its coefficient is 1. Here, 1 equal to button, and cursor comes here. And it is dancing there. Then, the coefficient of lambda, minus 4. And minus 4 equal to button. And cursor comes here. Okay. Now, the constant term. What is the constant term? 7, and 7 equal to button. And press the equal to button again one more times. And you are on the display of calculator, you are getting 2 plus or minus 1.732i. 2 plus minus 2, the values of lambda you are getting. First one is lambda 1 equal to 2 plus 1 plus 1.732i. And lambda 2 equal to 2 minus 1.732i. These are the characteristic roots. And in examination, not necessary for verification, but In a regular class, you can verify whether lambda 1 and lambda 2 are correct or not. You have to verify. Verification of solution. Verification of solution says that summation of lambda equal to 4, not minus 4 or plus 4, this 4. And the second property is the product of lambda equal to constant term 7. That is 7. And you can verify. Summation of lambda equal to what? Lambda 1 plus lambda 2. The 2 plus 1.732i plus 2 minus 1.732i. Then 1.732i plus minus getting cancelled. 2 plus 2, 4. Look here. 4 you got and 4 also you got here. Okay. Then next, the product of lambda means lambda 1 into lambda 2. Then into bracket 2 plus 1.732i, close the bracket, next bracket 2 minus 1.732i, and look here. This you can do it in calculator for your information. And on button, press the on button in calculator and mode button and press the 2 button. You brought the calculator to the complex mode. The complex mode. Then you can look here inside. You will take the bracket 2 equal to button plus 1 equal to button 0.7 equal to button 3 equal to button 3 equal to button 2 equal to button and I is shift and in the calculator the I button you have to press. That is the shift and ENG. That is okay, and I button. Then close the bracket and next bracket 2 minus 1.732i and equal to button. You are getting 7 on display of a calculator. Look here, 7 is here, 7 is here. Means the roots are, characteristic roots are correct only. Then verification of Cayley-Hamilton theorem now. What is Cayley-Hamilton theorem? The every square matrix satisfies its characteristic equation. What is characteristic equation? We are having lambda square minus 4 lambda plus 7 equal to 0. Now put lambda equal to a and multiply this constant 7 by I in the equation 1. Okay. Now see. The a square, lambda square means a square minus 4 lambda minus 4a plus 7 is there. You multiply the constant by I equal 7i equal to 0. Means this is verification of Cayley-Hamilton theorem. The how to verify LHS equal to RHS. 0 you have to get. Take LHS and check that it should be 0 or not. Then look here. A square means matrix A into A. A means 2 minus 1, 3, 2. And 2 minus 1, 3, 2. Minus 4, 2 minus 1, 3, 2. Plus 7, 1, 0, 0, 1. Okay. Then how to do in calculator, I am telling you, my dear students. On the calculator, press the mode button and press the 6th button. 6th button and you have to create this A and again 1 button. And what is the dimension of this A? How many rows? 2 rows, 2 columns. Means you press the 5th button. Then such a dialog box is opened there. Look here. 2 by 2 matrix. And you enter the values. 2 equal to button, minus 1 equal to button, 3 equal to button, 2 equal to button. And you entered the value. You created the matrix A. Then you create I also. Okay. Then AC button, then shift and 4th button. Then we have to create this I matrix in B. Then you press the 4th button and press the dimension. Look here. Press the shift 4th button. Then we have to create this I. We have to create this I. Means you press the dimension button. And where we have to do, we have to store it in matrix B and press the 2nd button. And it asks what is the dimension of the B. Means again 5th button. Then such a dialog box is opened there. Look here, 1 equal to button, 0 equal to button, 0 equal to button, 1 equal to button. You created I also in calculator memory. then AC button. Look here, my dear students. Then, see here. Now after this, you press the AC button and shift and fourth button. Look here. What I want here, A. Matrix A I want. You press the 3. Look here. Now, if you press the 3 on the display of calculator, mat A is coming. And you press the X square button. X square button means it becomes A square. And equal to button. You are getting on the display of calculator minus 1 minus 4, 12, 1. Means the calculator multiplies these two the matrices and gives final answer in calculator only. Then again AC button. Then look here, minus 4 is there. Okay. And minus 4 and into and again shift, again matrix. Then what we want there? 3. Means minus on the display of calculator, minus 4 mat A has came there. Mat 3. Okay. And mat A, not 3. This is A. Then you press the equal to button. Then you are getting this value. I have shifted this minus sign inside the A. Why means it becomes easy for us to add them. Minus 8, 4, minus 12, 8 you are getting on display of the calculator. Plus, look here. You write a plus there. And what is here? 7. Then AC button, 7 into. Then shift mat. The means fourth button. Then what I want. And this is identity matrix where we have told and mat B means 4. Then on the display of calculator 7 mat B came there. Okay. Now these are the share calculator notation I am giving and press equal to button. See this value is coming 7007. You can add simply, look here, you write directly 0000. But you can also verify 1 minus 8. 1 minus 8 plus 7 is 0. Look here, minus 4 plus 0. 0. Look here, 12 minus 12 plus 12 minus 12, 0 plus 0 and 0. Look here, the 1 minus 8. 7 minus 7 minus 7 plus 7 0. Look here and 0 RHS. This verifies the Cayley-Hamilton theorem. Means LHS equal to RHS. Look here. RHS 0 you got. Then look here. Find the A inverse. Then how to find the A inverse? Look here. This Cayley-Hamilton equation verification equation 2. You multiply this by A inverse. Multiply the equation 2 by equation 2, that is A square minus 4A plus 7I, and by A inverse on both sides. And also use A into A inverse equal to I, and I into A equal to A, and I into A inverse equal to A. You can, these are all identities which you have studied in PUC. Look here. A square into A inverse. Look here. A square into A inverse. Minus 4A into A inverse. 7I into A inverse equal to 0 into A inverse. Look here. And this A square can be written as A into A inverse. And look here, A into A inverse is I and minus 4I. Then 7. The 7 I into A inverse is A inverse. And this is 0 into A inverse is 0. Look here, my dear students. Then look here, A into A inverse is I. A into I is A only. And these remains as it is. Okay. Now, next time. See here. 7A inverse equal to 4I minus A. Then 4I means I, the matrix should be multiplied by 4. Means 4, 0, 0, 4. And plus, this is minus, but I made a plus. I sent that minus I inside the A. Minus 2, 1, minus 3, 2. And 4 minus 2, 2. And 0 plus 1. Look here. 4, you have to add minus 2 here. 4 minus 2, 2. And 0 plus 1 plus 1. And 0 minus 3, 4 minus 2, 2. And look here. This is equal to 7 A inverse. But I want only A inverse. A inverse is, and this 2, the matrix 2, 1 minus 3, 2 divided by 7. This is the answer. Okay. Now, the verification, whether this solution is correct or A inverse is correct or not, you can verify. Then A inverse equal to A dj A and divided by determinant of A. Now, look here. You, how to find out the, for second order matrix, 2 by 2 matrix, the adjoint of A can find out by interchanging the principal diagonals and changing the sign of secondary diagonals. And 2 and 2. Interchange means same it is. And here -1 is there in A, it becomes a plus. And +3 is there, it becomes change the sign of secondary diagonals. Interchange the principal diagonals, change the sign of a secondary diagonal. That is adjoint A. You are got it. And divided by the determinant of 7, already you have found out 7. Look here, both are same. In this way, you have to do them. My dear students, once again, I humbly request you, please subscribe to my channel and also comment and share this video to your friends. Best of luck. Nice time. Good day. We can meet you in other